Action potential travels down the axon of the nerve cell, causing channels for calcium to open and calcium ions flood into the cell. Calcium ions cause the synaptic vesicles to fuse with the cell membrane. This causes the release of acetylcholine into the synaptic cleft. The acetylcholine goes to the motor end plate of the muscle cell and attaches to acetylcholine receptors. This causes the sodium-potassium pump to open, and as sodium flows into the muscle cell, potassium will flow into the synaptic cleft, which causes a depolarization and an action potential to develop. Action potential travels down the sarcolemma, and acetylcholine esterase breaks down acetylcholine into acetic acid and choline, which go back into the nerve cell. They are rebuilt into acetylcholine and placed in synaptic vesicles. Action potential travels across the sarcolemma and T-tubules and opens calcium channels so that calcium flows from the sarcoplasmic reticulum to the myofibrils. This calcium attaches to the troponin, which pulls the tropomyosin off of the active sites. The active sites on the actin molecules are open and exposed. ATP from the mitochondria attaches to the myosin head and becomes ADP when the myosin head enters a high energy state. The high energy myosin head attaches to the active site on actin and releases the ADP, forming a cross bridge. When it releases the ADP, the myosin head will go to the low energy state and slides the thin myofilaments along the thick myofilaments. ATP attaches to the low energy myosin head and detaches it from the active site. ATP is needed to return the calcium via a calcium pump to the sarcoplasmic reticulum because there is a greater concentration of calcium in the terminal cisternae of the sarcoplasmic reticulum. Calsequestrin is needed to store the calcium in the terminal cisternae of the sarcoplasmic reticulum. Calsequestrin is needed to store the calcium in the terminal cisternae of the sarcoplasmic reticulum. The sarcomere is a highly ordered unit of thick and thin filaments and is the basic unit of striated muscle, and it is the contractile unit. The A band is the length of the thick filaments. The I band is the distance between the A bands and is made up of thin filaments. The Z line is where thin filaments attach. The distance from one Z line to another Z line is one sarcomere. The H band is where there is no overlapping of thick filaments. And the M line is a line of molecules that runs down the center of the sarcomere and gives the thick filaments an attachment site. This is a muscle with a fascicle protruding from it. The fascicle is a bundle of muscle fibers. One myofiber is the same thing as a muscle fiber or muscle cell. The terms are interchangeable. Thin and thick myofibrils make up each of the myofibers.